Professor Marcus Bennett walked into his office that Tuesday morning with a smile on his face. Today was going to be special. Today was the day he had been planning for months. He sat down at his desk and looked at the stack of papers in front of him. Each paper had a math problem written on it. These were not ordinary problems. These were the kind of problems that made graduate students cry. Marcus had been teaching calculus at Stanford University for 15 years. In all those years, he had never met a celebrity who could do real math. Not the simple stuff they taught in high school. Real math. The kind that required years of study and a sharp mind. The kind that separated the truly intelligent from those who just pretended to be smart. His annual celebrity challenge had become famous across the campus. Every year, he invited someone famous to come and try to solve math problems in front of his students. Every year, the same thing happened. The celebrity would struggle, make mistakes, and eventually give up. The students would laugh. The media would write articles about how book smarts were different from street smarts. And Marcus would feel satisfied that he had shown everyone the difference between real intelligence and fake intelligence. This year was going to be even better. This year, his guest was Keanu Reeves. Marcus had nothing against actors personally. They worked hard at their jobs just like everyone else. But he was tired of people thinking that playing smart characters in movies made someone actually smart. He was tired of hearing people talk about how wise and thoughtful certain actors were just because they gave good interviews. Real wisdom came from real knowledge. Real knowledge came from years of study. The phone on his desk rang. It was his assistant, Linda. "Professor Bennett, the media people are here to set up their cameras. Should I let them into the lecture hall?" "Yes. Let them in. Make sure they have a good view of the main board. I want everyone to see this clearly." Marcus got up and walked to his window. He could see students gathering outside the lecture hall already, even though the event was not supposed to start for another 2 hours. Word had spread quickly around campus. Everyone wanted to see what would happen when Hollywood met higher mathematics. He picked up his phone and called his friend Robert, who taught physics at Berkeley. "Robert, are you coming to watch today?" "Would not miss it for the world, Marcus. I heard you have some really tough problems prepared." "The toughest?" "I started with some standard calculus, but then I move into graduate-level material. Complex analysis, differential equations, even some topology. If he gets through the first 3 problems, I will eat my hat." Robert laughed. "You are being cruel, Marcus. The man is just an actor." "Exactly my point. People need to understand that there's a difference between playing a genius and being one." Marcus hung up and returned to his papers. He had spent weeks choosing these problems. The first few were difficult, but not impossible for someone with a strong undergraduate background in mathematics. The middle problems required graduate-level knowledge. The final problems were from his own research, problems that he had been working on for months without finding complete solutions. He was particularly proud of the 7th problem on his list. It involved chaos theory and fractal geometry. He had been trying to solve it himself for the better part of a year. If by some miracle the actor made it that far, Marcus was confident that would be the end of the show. The door to his office opened, and his department head, Professor Nancy Williams, walked in. "Marcus, I hope you know what you are doing today." Of course I know what I am doing. I am demonstrating the value of real education versus celebrity culture." Nancy sat down in the chair across from his desk. "You know, Keanu Reeves has a reputation for being quite intelligent and humble. Are you sure you want to risk embarrassing him publicly?" Marcus waved his hand dismissively. "Nancy, I have been doing this for 5 years. Trust me, I know how these things go. He will struggle with the second problem, maybe get lucky with the third, and then we will all have a good laugh about it. No one gets embarrassed. Everyone learns something. If you say so, just remember, The whole thing is being filmed. If something goes wrong, it will be all over the internet by tonight." After Nancy left, Marcus gathered his papers and headed toward the lecture hall. As he walked across campus, students waved at him and wished him luck. Some of them were carrying signs that said things like "Team Professor" and "Math Rules." Marcus felt like a celebrity himself. The lecture hall could hold 300 students, and every seat was filled. Camera crews had set up their equipment in the back. Reporters sat in the front row with their notebooks ready. Faculty members from other departments had come to watch. Even some people from the local news stations were there. Marcus walked the front of the room and tested the microphone. The large digital board behind him was clean and ready for use. He had practiced writing on it many times to make sure his handwriting would be clear for the cameras. At exactly 2 o'clock, the side door opened and Keanu Reeves walked in. Marcus had seen him in movies, of course, but meeting someone in person was always different. The actor was dressed simply in jeans and a black t-shirt. He looked relaxed and friendly. He walked over to Marcus and shook his hand. "Thank you for having me, Professor. I appreciate you taking the time to do this." "Thank you for coming. I hope you are ready for a challenge." Keanu smiled. "I will do my best." Marcus turned to face the audience. The room became quiet. "Ladies and gentlemen, welcome to our annual Celebrity Challenge. Today we have with us Mr. Keanu Reeves, who has agreed to help us explore the relationship between entertainment and education. Mr. Reeves will attempt to solve a series of mathematical problems of increasing difficulty. Let us see how far we can go." The audience clapped politely. Marcus looked at Keanu, who was standing calmly beside the whiteboard, looking comfortable and ready. "Are you ready to begin, Mr. Reeves?" "Ready when you are, Professor." Marcus picked up his first problem sheet. This was going to be fun. Marcus walked to the large digital board and picked up the electronic marker. He had decided to start with something that looked impressive, but was still manageable for someone with basic calculus knowledge. He wanted to warm up the audience before moving to the really difficult stuff. "Our first problem involves integration," Marcus announced to the room. "This is the kind of problem my advanced students work on during their second year." He began writing on the board. The problem filled up half the screen with symbols, fractions, and Greek letters. It was a definite integral that required trigonometric substitution and partial fraction decomposition. To most people in the audience, it looked like a foreign language. Marcus stepped back and admired his work. "Mr. Reeves, please take your time with this. There is no shame in asking for help or admitting when you are stuck." Several students in the audience chuckled. This was exactly what they had come to see. The camera zoomed in on Keanu's face, expecting to capture the moment of confusion and defeat. Keanu walked up to the board and studied the problem for about 30 seconds. He picked up a marker and began to write. Marcus watched with interest. He expected to see some fumbling around, maybe an attempt at the basic setup before the actor got lost in the complexity. Instead, he saw something that made him blink twice. Keanu was writing quickly and confidently. His handwriting was neat and clear. More importantly, his approach was completely correct. He identified the need for trigonometric substitution immediately and chose the right substitution without hesitation. "Interesting choice," Marcus said, trying to hide his surprise. "That is indeed the correct approach." Keanu did not respond. He was too focused on his work. He moved through the substitution, step by step, making no errors. When he reached the point where partial fractions were needed, he set up the decomposition perfectly. The room had become very quiet. Students were leaning forward in their seats, trying to follow the work on the board. The graduate students in the audience were nodding their heads in approval. This was not what anyone had expected to see. Marcus felt a small knot forming in his stomach. This was supposed to be the easy part. The warm-up. The part where the celebrity would struggle a little, but maybe get lucky with some guidance. Instead, he was watching Keanu work through the problem like he had done it 100 times before. Within 6 minutes, Keanu had completed the entire solution. He stepped back from the board and set down his marker. "Is that correct, Professor?" Marcus walked up to the board and checked the work line by line. The setup was perfect. The algebra was flawless. The final answer was exactly right. Not only that, but Keanu had chosen the most efficient path through the problem. There were no wasted steps or unnecessary complications. "Yes," Marcus said slowly. "That is completely correct." The audience burst into applause. Several students were talking excitedly to each other. The reporters in the front row were writing furiously in their notebooks. Marcus felt his confidence shake a little, but he quickly recovered. One problem proved nothing. Maybe Keanu had studied this particular type of problem before coming here. Maybe he had gotten lucky. Maybe someone had coached him on integration techniques. "Very good, Mr. Reeves. That was well done. However, that was just our warm-up problem. Let us move on to something a bit more challenging." Marcus erased the board and began writing the second problem. This one was much harder. It involved multiple variables, chain rule applications, and required understanding of three-dimensional geometry. It was the kind of problem that separated the casual math students from the serious ones. "This problem requires multivariable calculus," Marcus announced. "We are looking for the maximum value of this function subject to the given constraints." He finished writing and turned to face Keanu. The actor was already studying the problem, his eyes moving across the board methodically. "This is a constraint optimization problem," Keanu said quietly. "We can use Lagrange multipliers." Marcus felt his eyebrows rise. Lagrange multipliers were not something most people knew about unless they had taken advanced calculus. It was exactly the right technique for this problem, but it was not obvious to someone without proper training. "That is correct," Marcus said. "Please proceed." Keanu began working again. This time, Marcus watched more carefully. He wanted to see if this was real knowledge or just lucky guessing. What he saw made him increasingly uncomfortable. Keanu set up the Lagrangian correctly on his first try. He computed the partial derivatives without making any errors. When he reached the point where he needed to solve the system of equations, he used a clever algebraic manipulation that even Marcus had not thought of when he first solved this problem. The solution process took about 12 minutes. When Keanu finished, he had not only found the correct answer, but had also verified it by checking the second-order conditions to confirm it was indeed a maximum. Marcus checked the work. Again, it was perfect. More than perfect. It was elegant. The audience was no longer just politely interested. People were genuinely excited. Students were taking pictures of the board with their phones. Some of the faculty members were whispering to each other with surprised expressions. Marcus felt sweat forming on his forehead. This was not going according to plan. He had expected to be gently correcting mistakes and guiding Keanu through the basics by now. Instead, he was looking at graduate-level work that was better than what most of his own students could produce. "Excellent work," Marcus said, his voice sounding a little strained. "That was a very sophisticated approach." Keanu nodded politely. "Thank you. What is the next problem?" Marcus looked at his list of problems. He had planned to work through them gradually, building difficulty slowly. But now he was wondering if he needed to skip ahead. Maybe Keanu had studied these specific types of problems. Maybe he needed to jump to something more advanced to find the actor's limits. "Well," Marcus said, "I think we can move on to some more advanced material. Let me give you something that requires a bit more mathematical maturity." He began writing the third problem on the board. This one involved differential equations and complex analysis. It was the kind of problem that graduate students sometimes struggled with. If Keanu could handle this one, Marcus would have to seriously Reconsider his assumptions. As he wrote, Marcus could hear the audience buzzing with excitement. Someone behind him said, "This is incredible." Another voice said, "I did not expect this at all." Marcus finished writing and stepped back. The problem filled most of the board. It looked intimidating even to him. "This problem combines several areas of advanced mathematics," Marcus announced. "Take your time, Mr. Reeves. This is significantly more difficult than what we have done so far." Keanu approached the board and studied the problem for a full minute. Marcus watched his face, looking for signs of confusion or hesitation. What he saw instead was the focused concentration of someone who was thinking deeply about a challenging but familiar type of problem. Then, Keanu picked up his marker and began to write again. Keanu began working on the third problem with the same calm focus he had shown before. Marcus watched every move, looking for any sign that the actor was finally out of his depth. The problem involved a complex differential equation that required both analytical methods and numerical approximation techniques. It was the kind of problem that took Marcus's graduate students weeks to fully understand. Within the first few minutes, it became clear that Keanu understood exactly what he was dealing with. He identified the type of differential equation correctly and began setting up the solution using separation of variables. His work was clean and methodical, but then something unexpected happened. Keanu stopped writing and stood back from the board. He looked at the problem for a long moment, then turned to Marcus. "Professor Bennett, would it be possible to get a second whiteboard?" Marcus felt confused. "A second board? Why do you need a second board?" "I want to try two different approaches to this problem. The analytical solution and a numerical approximation. I think it would be interesting to compare them." The room fell completely silent. Marcus stared at Keanu, not sure he had heard correctly. Two different approaches? Most graduate students were happy if they could find one approach that worked. "Of course," Marcus said slowly. "Linda, can you bring in the portable whiteboard from my office?" While they waited for the second board, Marcus tried to process what was happening. This was not going according to his plan at all. He had expected to be helping Keanu through basic concepts by now. Instead, the actor was asking for more space to show off advanced techniques. The portable board arrived, and Keanu positioned it next to the main board. He picked up markers in both hands and began working on both boards simultaneously. On the left board, he continued with the analytical approach he had started. He worked through the separation of variables, integrated both sides, and began solving for the constant of integration using the given boundary conditions. On the right board, he started something completely different. He began setting up a numerical method that Marcus recognized as a modified Runge-Kutta approach, but with some variations that Marcus had never seen before. "What numerical method are you using?" Marcus asked, unable to hide his curiosity. "It is a hybrid approach," Keanu said without stopping his work. "I am combining fourth-order Runge-Kutta with adaptive step sizing, but I am also incorporating some stability corrections that help with stiff equations." Marcus felt his mouth open slightly. Stiff equations were an advanced topic in numerical analysis. The fact that Keanu not only knew about them, but was implementing stability corrections on the spot, was remarkable. The audience was completely mesmerized. Students were standing up to get better views of both boards. The camera crews were moving around to capture different angles. Several faculty members had moved closer to the front of the room. Professor Williams, the department head, was sitting in the third row with a look of complete amazement on her face. She caught Marcus's eye and mouthed the words, "What is happening?" Marcus did not have an answer for her. Keanu worked steadily on both boards for about 20 minutes. His analytical solution progressed smoothly through integration and algebraic manipulation. His numerical approach involved setting up iteration formulas and stability criteria. When he finished the analytical solution, He got an exact answer expressed in terms of exponential and trigonometric functions. When he completed his numerical setup, he began calculating approximation values by hand, working through several iterations to demonstrate the convergence of his method. The analytical solution gives us the exact form, Keanu said, pointing to the left board. The numerical approach gives us specific values that we can use for practical applications. If we compare them at a few test points, he began calculating values using both methods and comparing them. The agreement was perfect within the precision of his hand calculations. Marcus walked up to examine both solutions. The analytical work was flawless. The numerical method was sophisticated and well implemented. But what impressed him most was the insight Keanu had shown in choosing to compare the two approaches. It demonstrated a deep understanding of when to use different mathematical tools. "This is graduate-level work," Marcus said quietly. "Actually, this is better than graduate-level work. Some of these techniques are quite advanced." The audience erupted in applause. This time, it was not just polite clapping. People were genuinely excited by what they had witnessed. Several students were cheering. Marcus felt a strange mixture of emotions. His plan to demonstrate the difference between real intelligence and celebrity wisdom was backfiring spectacularly. But at the same time, he was genuinely impressed by what he was seeing. As a mathematician, he could appreciate excellent work, regardless of who was producing it. Robert, his friend from Berkeley, was sitting in the audience with his mouth hanging open. He caught Marcus's attention and shook his head in disbelief. The reporters were writing frantically. One of them raised her hand. "Professor Bennett, is this level of mathematical ability common among actors?" Marcus did not know how to answer that question. "No," he said simply. "This is not common among anyone." Keanu had finished cleaning up his work on both boards and was standing quietly to the side. He did not seem particularly proud or excited about what he had accomplished. He just looked ready for whatever came next. Marcus looked down at his list of prepared problems. He had planned to work up to these gradually, but now he was wondering if he needed to skip even further ahead. His fourth and fifth problems were difficult, but based on what he had just seen, they might not be challenging enough. "Mr. Reeves," Marcus said, "I have to admit that your mathematical ability is far beyond what I expected. Would you be interested in tackling something even more challenging?" "Sure," Keanu said simply. "Whatever you think would be interesting." Marcus made a decision. He was going to skip ahead to problem number 7, the chaos theory problem that he had been working on for months. The problem that he was not sure he could solve completely himself. If Keanu could handle that, then Marcus would have to completely reconsider everything he thought he knew about intelligence, education, and the assumptions people make about each other. He walked to the board and began erasing Keanu's work to make room for the new problem. As he erased, he noticed that several people in the audience were taking pictures of the solutions before they disappeared. "Our next problem," Marcus announced, "comes from my own current research. It involves chaos theory and fractal geometry. I will be honest with everyone here. I do not have a complete solution to this problem myself." The room became very quiet again. Marcus began writing the problem on the board. It was complex and abstract, involving strange attractors, dimensional analysis, and nonlinear dynamics. When he finished writing, the board was covered with equations and symbols that looked like a foreign language, even to most of the mathematicians in the audience. He turned to face Keanu, expecting to finally see some sign of uncertainty or confusion. Instead, Keanu was studying the problem with the same focused attention he had given to all the others. Keanu stood in front of the chaos theory problem for several minutes without moving. The entire lecture hall was silent. Marcus could hear his own heartbeat. This was the moment he had been waiting for. Surely this would be where the actor finally met his match. The problem on the board looked like something from another world. It dealt with strange attractors in three-dimensional phase space, fractal dimensions, and nonlinear feedback systems. Marcus had been struggling with it for 8 months as part of his research into weather prediction models. After what felt like forever, Keanu turned to Marcus. "Professor Bennett, can you clarify something for me? When you say the system has bounded trajectories, are you assuming periodic boundary conditions, or are you working with a finite domain?" Marcus felt his eyes widen. That was exactly the right question to ask. It was the kind of question that showed deep understanding of the mathematical structures involved. "The boundary conditions are periodic," Marcus replied. "We are essentially working on a torus." Keanu nodded. "And what about the parameter values? Are we looking for general solutions, or do you have specific values in mind for the control parameters?" Again, this was precisely the kind of clarifying question that a real expert would ask. Marcus found himself answering as if he were talking to a colleague rather than explaining things to a student. "The parameter values are variable. I am interested in understanding how the system behavior changes as we move through parameter space." "Ah," Keanu said. "So you are looking at bifurcation analysis as well." Marcus nearly dropped his marker. Bifurcation analysis was an extremely advanced topic. Most graduate students never encountered it unless they specialized in dynamical systems theory. Keanu began working on the problem, but his approach was completely different from anything Marcus had seen before. Instead of trying to solve the equations directly, he started by sketching diagrams that showed the geometric structure of the problem. He drew phase portraits and flow diagrams that helped visualize what the equations were describing. "The key insight," Keanu said as he worked, "is that this system has hidden symmetries that are not obvious from the original formulation. If we change variables using this transformation..." He began writing a complex coordinate transformation that Marcus had never seen before. As Keanu worked through the algebra, Marcus realized that the transformation was revealing structure in the problem that had been completely hidden. "Where did you learn this transformation?" Marcus asked. "I derived it," Keanu said simply. "The original system has a rotational symmetry that becomes clear if you look at it in the right coordinate system." Marcus stared at the board. In all his months of working on this problem, he had never noticed the symmetry that Keanu was pointing out. Now that he saw it, it seemed obvious, but finding it required real mathematical insight. Keanu continued working, but now he was doing something that Marcus had never seen anyone do in a classroom setting. He was teaching, not just solving the problem, but explaining his thought process to the entire audience. "The beautiful thing about chaos theory," Keanu said as he wrote, "is that it shows us how simple rules can create incredibly complex behavior. But it also shows us that even in the complexity, there are patterns and structures that we can understand." He was breaking down advanced mathematical concepts and making them accessible to everyone in the room. Students who had never heard of chaos theory before were following along with his explanations. Faculty members were taking notes. Marcus found himself learning from Keanu's approach. The way the actor was handling the problem was giving Marcus new ideas about his own research. As Keanu worked through the mathematics, he began incorporating techniques from other fields. He used methods from quantum mechanics to handle the probabilistic aspects of the chaotic behavior. He applied concepts from information theory to measure the complexity of the system's output. "This is remarkable," whispered Professor Williams from her seat in the audience. "He is connecting ideas from completely different areas of mathematics and physics." The solution that emerged was unlike anything Marcus had imagined. Keanu had not just solved the problem. He had created an entirely new framework for understanding this type of dynamical system. His approach revealed connections between chaos theory, quantum mechanics, and information theory that could revolutionize the field. When Keanu finished writing, he stepped back from the board. The solution covered both whiteboards and part of the wall. It was comprehensive, elegant, and groundbreaking. This gives us a complete characterization of the system's behavior, Keanu said. We can predict the onset of chaos, measure the fractal dimension of the attractors, and even quantify the information content of the chaotic signals. Marcus walked up to the boards and began reading through the solution. Every line was correct. Every step was justified. But more than that, the approach was innovative and insightful in ways that Marcus had never imagined possible. Mr. Reeves, Marcus said slowly, this is not just a solution to my research problem. This is a breakthrough. This work could be published in the top mathematics journals. The audience was completely silent. Everyone understood that they were witnessing something extraordinary, even if they could not follow all the mathematical details. Then one of the graduate students, a young woman named Lisa Martinez, raised her hand. Professor Bennett, I have a question, but it is not about the mathematics. What is your question, Lisa? Lisa had her laptop open and was looking at the screen with a puzzled expression. I have been searching for papers on chaos theory and dynamical systems while Mr. Reeves was working. I found several research papers that use very similar techniques to what we just saw. The author is listed as K.C. Reeves. The room became even quieter, if that was possible. Can you show us what you found? Marcus asked. Lisa connected her laptop to the projection system. The main screen displayed a list of academic papers from prestigious mathematics journals. The titles included phrases like novel approaches to chaotic dynamical systems, information theoretic methods in nonlinear analysis, and quantum mechanical analogies in classical chaos. All of the papers were authored by K.C. Reeves. Marcus stared at the screen. K.C. Reeves, Keanu Charles Reeves. Mr. Reeves, Marcus said quietly, are these your papers? Keanu looked at the screen and nodded. Yes, those are mine. How many papers have you published? In pure mathematics? About 15 over the past 7 years. I also have some work in applied mathematics and theoretical physics. The lecture hall erupted. Students were talking excitedly to each other. Faculty members were pulling out their phones to search for more information. The reporters were frantically writing notes. Marcus felt the room spinning around him. He had spent the entire afternoon trying to embarrass someone who was actually a published researcher in advanced mathematics. Someone who had been contributing to the field at the highest levels for years. Why? Marcus asked. Why did you not tell me who you were? Keanu shrugged. You did not ask. Besides, I thought this was supposed to be about the mathematics, not about who I am. Marcus realized that everything he thought he knew about this situation had been completely wrong. He had not been teaching a celebrity about mathematics. A real mathematician had been patiently allowing him to test problems that were probably routine exercises compared to the research Keanu was actually working on. I owe you an apology, Marcus said. No apology needed, Keanu replied. This was fun. I enjoyed working through these problems with an audience. It is not often I get to share this side of my work with so many people. Lisa Martinez was not finished with her discoveries. She continued typing on her laptop while the room buzzed with excitement around her. Her fingers moved quickly across the keyboard as she searched through academic databases and research journals. Professor Bennett, she called out again. I think everyone needs to see this. The room quieted down as Lisa connected her laptop to the main screen again. This time, she displayed a detailed academic profile that made everyone gasp. The screen showed a list of publications that went far beyond the 15 papers Keanu had mentioned. There were research articles in mathematics journals, but also papers in physics, computer science, and engineering. The publication dates went back over 10 years, covering topics from quantum computing to artificial intelligence to climate modeling. According to this database, Lisa said, her voice filled with amazement, K.C. Reeves has published 43 peer-reviewed papers across multiple fields. His work has been cited over 2,000 times by other researchers. Marcus felt like he needed to sit down. 43 papers, 2,000 citations. These were the numbers of a serious academic researcher, not someone who dabbled in mathematics as a hobby. There is more, Lisa continued. He has been a consultant mathematician for NASA, the Department of Energy, and several major technology companies. He also has patents in computational methods and machine learning algorithms. The students in the audience were now openly staring at Keanu, who seemed uncomfortable with all the attention. He stood quietly near the whiteboard, looking like he wanted to disappear. Professor Williams stood up from her seat. "Mr. Reeves, forgive me for asking, but why is none of this information publicly known? You are clearly one of the leading researchers in several fields, yet no one seems to know about your academic work." Keanu was quiet for a moment before answering. "I prefer to keep my different careers separate. When I am working on a movie, I focus on acting. When I am doing research, I focus on mathematics and science. I publish under my initials to avoid drawing attention to my academic work." "But why?" asked Marcus. "Most people would be proud to have accomplishments like these." "Because," Keanu said simply, "I want my research to be judged on its own merits, not because of who wrote it. If people knew that an actor had written a paper on quantum mechanics, they might dismiss it without reading it properly. Or they might give it more attention than it deserves just because of my name. Neither of those things would be good for science." Marcus was beginning to understand how completely wrong his assumptions had been. He had invited Keanu here to demonstrate the difference between real intelligence and celebrity culture. Instead, he had unknowingly invited one of the most accomplished researchers in the country to solve routine problems in front of an audience. "How long have you been doing this?" Marcus asked. "I have been interested in mathematics since I was a child," Keanu replied. "I started taking university courses when I was 16, during breaks from filming. Over the years, I have studied at various institutions around the world. MET, Cambridge, the Sorbonne, Tokyo University. Whenever I had time between projects, I would audit graduate courses or work with research groups." Lisa was still searching through databases on her laptop. "Professor Bennett, look at this. He has a PhD in applied mathematics from Cambridge University. He completed it in 2019. The room was completely silent now. Everyone was trying to process this information. Marcus felt like everything he thought he knew about education, intelligence, and celebrity culture had been turned upside down. "You have a PhD from Cambridge?" Marcus asked weakly. "Yes. I worked on problems related to network theory and complex systems. My advisor was Professor Sarah Thompson in the mathematics department." Marcus knew Professor Thompson by reputation. She was one of the most respected mathematicians in the world, known for only accepting the most brilliant students. "The thing is," Keanu continued, "most people do not want to hear about my academic interests when they meet me. They want to talk about movies. So I learned early on to keep these parts of my life separate. It is easier for everyone that way." Robert, Marcus's friend from Berkeley, raised his hand. "Mr. Reeves, I have a question about your paper on quantum error correction. The method you developed has been cited by our research group several times. We had no idea we were citing you." Keanu smiled for the first time since the academic discoveries had begun. That paper was particularly fun to work on. The connection between quantum error correction and classical coding theory is fascinating. You have been helping advance our research for years without us knowing it," Robert said with amazement. Marcus looked around the lecture hall. The students were hanging on every word. The faculty members were asking questions about specific research papers. The reporters were frantically taking notes about this unexpected story. One of the students, a young man named Kevin, raised his hand. "Mr. Reeves, if you are such an accomplished researcher, why do you still act in movies?" Because I love both, Keanu said. Acting and mathematics use different parts of my mind. They both challenge me in different ways. I do not see why I should have to choose between them. Another student asked, "Do you ever use mathematics in your acting?" More often than you might think. Understanding physics helps with action scenes. Game theory is useful for understanding character motivations. Even basic statistics can help you understand how audiences might react to different choices. Marcus realized that he was witnessing something remarkable. Not just the discovery that a famous actor was also a brilliant mathematician, but the realization that people could be far more complex and multi-talented than anyone assumed. "Mr. Reeves," Marcus said, "I owe you more than an apology. I brought you here today because I wanted to demonstrate the difference between real intelligence and fake intelligence. Instead, you have taught me that my assumptions about intelligence were completely wrong." "Intelligence comes in many forms," Keanu said. "Some people are brilliant at mathematics but cannot tell a story to save their lives. Some people can memorize every line of Shakespeare but struggle with basic algebra. Some people have incredible emotional intelligence, but find academic subjects difficult. The mistake is thinking that one type of intelligence is more valuable than others." Professor Williams nodded. "Mr. Reeves, would you consider giving a guest lecture in our department sometime? I think our students would benefit enormously from hearing about your research." "I would be happy to," Keanu replied. "But perhaps we could focus on the mathematics rather than the celebrity angle." Marcus looked at his list of prepared problems. He still had several left, but they seemed pointless now. Instead of trying to stump Keanu with difficult mathematics, he found himself wanting to learn from him. "Mr. Reeves, would you be willing to tell us about your current research? What problems are you working on now?" Keanu's eyes lit up. "Actually, I am working on something that might interest everyone here. It combines chaos theory, machine learning, and climate modeling. The goal is to improve long-term weather prediction by understanding the mathematical structure of atmospheric dynamics." The audience leaned forward with genuine interest. This was no longer about testing a celebrity's knowledge. This had become a real academic discussion with one of the leading researchers in the field. Keanu walked to the whiteboard and began sketching diagrams of atmospheric flow patterns. His drawings were simple but clear, showing how air currents moved around the planet in complex spirals and loops. "The problem with weather prediction," he explained to the fascinated audience, "is that the atmosphere is a chaotic system. Small changes in one place can create huge effects somewhere else. We call this the butterfly effect." Marcus watched as Keanu transformed the lecture hall into an advanced seminar on climate mathematics. The actor was explaining concepts that Marcus himself found challenging, but he was doing it in a way that everyone could understand. "Traditional weather models try to solve the equations directly," Keanu continued, drawing mathematical formulas alongside his atmospheric diagrams. "But I think we can do better by combining chaos theory with machine learning. If we can teach computers to recognize patterns in chaotic data, we might be able to predict weather changes weeks or even months in advance." A graduate student named David raised his hand. "How do you handle the computational complexity? The atmosphere has billions of variables." "That is where the mathematics becomes really interesting," Keanu replied. He began writing equations that showed how to reduce the complexity while preserving the essential dynamics of the system. "We use dimensional reduction techniques to focus on the most important variables, then apply machine learning to find patterns that humans might miss." Marcus found himself taking notes like a student. The approach Keanu was describing could revolutionize weather prediction and climate science. It was the kind of breakthrough that could help humanity prepare for climate change and save countless lives. "Mr. Reeves," said Professor Williams, "this research sounds incredibly important. Have you published these results yet?" "I am working on a paper with colleagues at 3 different universities," Keanu said. We hope to submit it for publication next month. But the real test will be implementing the system and seeing if it works in practice. One of the reporters in the front row raised her hand. Mr. Reeves, can you help us understand something? You have clearly accomplished remarkable things in both entertainment and science. What does this say about human potential in general? Keanu set down his marker and turned to face the audience. For the first time all afternoon, he looked serious and thoughtful. I think this whole situation today illustrates something important about people, he said. Every human being you meet is carrying hidden depths. Everyone has capabilities and knowledge and experiences that are not obvious from the outside. He gestured toward the audience. Look around this room. I guarantee that every person here knows things that would surprise the people sitting next to them. The student who seems quiet might be an amazing musician. The professor who teaches calculus might write poetry in his spare time. The reporter who covers science news might have grown up on a farm and know everything about agriculture. Marcus felt a strange sensation as he listened. Keanu was right. Marcus had spent 15 years teaching, and he realized that he rarely asked his students about their interests outside of mathematics. How many hidden talents and areas of expertise had he overlooked? The problem, Keanu continued, is that we put people in boxes. We see someone's job or their appearance or their age, and we assume that tells us everything about them. But humans are not simple. We are complex creatures with multiple interests and abilities. A young woman in the audience called out, "But how do you find time for everything? How do you balance acting and research and all your other interests?" You make choices about what matters to you, Keanu replied. Some people think I am crazy for trying to do both acting and mathematics. They say I should focus on one thing and become the best at it. But I think life is more interesting when you explore multiple passions. Marcus thought about his own life. He had devoted himself completely to mathematics and teaching. He had always been proud of his focus and dedication. But listening to Keanu made him wonder what other parts of himself he had neglected. There is another important point, Keanu said. When people assume that actors cannot be smart, or that mathematicians cannot be creative, they are limiting human potential. They are saying that humans can only be good at one type of thing. But that is not true. Humans are incredibly adaptable and capable of learning almost anything. Lisa, the graduate student who had discovered Keanu's publications, raised her hand. Do you think there are other people like you? People who have hidden expertise that no one knows about? Absolutely, Keanu said without hesitation. I meet them all the time. The taxi driver who speaks 5 languages. The waitress who has read every book ever written about history. The security guard who composes music. The janitor who understands electronics better than most engineers. Hidden expertise is everywhere if you take the time to look for it. Marcus felt himself nodding. He thought about the custodian in his building, an older man named Frank who cleaned the offices every evening. Marcus had never had a real conversation with Frank beyond saying hello. What did Frank know? What were his interests and experiences? The thing about humans, Keanu said, is that we are natural learners. Give a human being enough time and motivation, and they can master almost any skill. The barriers are usually not about ability. They are about opportunity, resources, and expectations. One of the faculty members asked, "What advice would you give to young people who want to pursue multiple interests like you have?" Do not let other people define your limitations, Keanu replied. If you are interested in something, learn about it. If you want to try something new, try it. The worst thing that can happen is that you will fail, and failure is just another form of learning. Marcus realized that the entire afternoon had been a powerful lesson, but not the lesson he had planned to teach. He had wanted to show the difference between real intelligence and fake intelligence. Instead, He had learned about the danger of assumptions and the importance of recognizing the hidden depths in every person. "Mr. Reeves," Marcus said, "I brought you here today because I thought I knew what intelligence looked like. I thought it had to come with certain credentials and follow certain patterns. You have shown me that intelligence is much more diverse and surprising than I realized." "Intelligence is not about credentials," Keanu said. "It is about curiosity, persistence, and the willingness to keep learning. Those qualities can be found in anyone, anywhere." The lecture hall erupted in applause, but this time it was different from the earlier applause. This was not just appreciation for mathematical skill. This was recognition of a deeper truth about human potential and the importance of looking beyond surface appearances. As the applause died down, Marcus looked out at his students and colleagues. Tomorrow, he decided, he would start asking different questions. He would try to learn about the hidden depths in the people around him. And maybe, he thought, he would explore some hidden parts of himself that he had neglected for too many years. The cameras were still rolling, capturing a moment that would soon spread around the world. But Marcus knew that the real impact of this afternoon would not be the viral video or the news articles. It would be the change in how people thought about human potential and the assumptions they made about each other. Keanu had given them all a gift, not just the gift of mathematical insight, but the gift of recognizing the extraordinary capabilities that exist within ordinary people everywhere.